Henry Cavendish, a name whispered in scientific circles, often with a mix of awe and curiosity, a man of immense wealth, yet reclusive habits that kept him away from the public eye. He was an enigma wrapped in a powdered wig, a figure both fascinating and mysterious.
Born in 1731, Cavendish shunned the limelight, preferring the company of his instruments to that of people, finding solace in solitude. His voice rarely rose above a mumble, his gaze often averted, avoiding direct interaction. Yet, behind this shy exterior resided a mind of extraordinary brilliance, a mind that would illuminate a hidden corner of the universe, revealing secrets long concealed.
Cavendish lived in a time of intellectual ferment, a period ripe with new ideas. The Enlightenment was sweeping through Europe, challenging old ideas and igniting new passions, transforming societies. In this era of reason and discovery, Cavendish found his calling, dedicating himself to the pursuit of knowledge.
He converted his London mansion into a grand laboratory, a temple dedicated to the pursuit of scientific truth, a sanctuary for his experiments. Here, surrounded by his beloved instruments and stacks of meticulously kept notebooks, he embarked on a lifelong exploration of the natural world, uncovering its mysteries one experiment at a time. The late 18th century was a time when alchemy was giving way to the rigor of modern chemistry. This period marked a significant shift in scientific thought and practice. It was a time when scientists were probing the very building blocks of our world, seeking to understand the fundamental principles that govern matter. They were like explorers charting a new continent, each discovery pushing back the boundaries of the known, revealing new realms of knowledge and understanding.
The air we breathe, the water we drink, the fire that warms us, these were no longer seen as mystical elements, but as substances with their own unique properties, ripe for investigation. Scientists began to unravel the mysteries of these elements, understanding their composition and behavior.
Cavendish was particularly intrigued by airs, as gases were then known. His curiosity led him to explore these invisible substances with great determination. He was fascinated by their invisibility, their elusiveness. The challenge of studying something that could not be seen with the naked eye was both daunting and exhilarating. What were they made of? How did they behave? These questions drove him to conduct meticulous experiments.
To explore these questions, Cavendish devised ingenious experiments in his basement laboratory. His workspace was filled with an array of scientific instruments, each carefully chosen for its purpose. He heated, cooled, combined, and separated various substances, meticulously observing the reactions and changes that occurred, carefully collecting and analyzing the resulting gases. His attention to detail and methodical approach were key to his success. Little did he know that one of these airs would secure his place in the annals of science. His discoveries would pave the way for future generations of scientists, forever changing our understanding of the natural world.
In a groundbreaking experiment in 1766, the renowned scientist Henry Cavendish set about investigating the reaction between metals and acids, a subject that had intrigued many before him but had never been fully understood. He carefully filled a flask with sulfuric acid, a substance known for its reactive properties, and then added shavings of zinc, a common metal.
The mixture immediately began to fizz and bubble, releasing energy in a visible and audible reaction. And then, a strange thing happened. A new air was produced, an air unlike any other I had encountered in my experiments. It was a moment of pure scientific discovery. This new air was lighter than ordinary air, and most curiously, it burned with a pale blue flame, a characteristic that set it apart from all known gases.
This was a pivotal moment in the history of chemistry, marking the discovery of a new element. Cavendish had unwittingly stumbled upon a new substance, an element that would later be recognized as the most abundant in the universe. Hydrogen, a cornerstone of modern chemistry.
Of course, I didn't know any of this at the time. To me, it was simply a fascinating new discovery. I called my discovery inflammable air and meticulously recorded its properties in my notebooks, noting every detail with precision. I noted its remarkable lightness, its extraordinary flammability, and the fact that it could be produced from various metals and acids, a discovery that would pave the way for future scientific breakthroughs.
The scientific community, initially skeptical, gradually began to take notice of Cavendish's findings. His meticulous experiments, his precise measurements, and his cautious interpretations lent weight to his claims.
The idea that there existed an air lighter than air itself, an air that could burn, captured the imagination of scientists across Europe.
Cavendish himself remained characteristically modest about his discovery. He published his findings in the Philosophical Transactions of the Royal Society, but he made no grand pronouncements, no sweeping claims.
He simply presented his observations, leaving it to others to grapple with their implications. It would be several years before the true significance of Cavendish's inflammable air would be fully understood.